Alright, we're going to draw some system schema and free body diagrams for the period of jumping. So here you're going to be sort of crouching, like sort of in the push-off stage. So we're accelerating upward. We're going to be off the ground. We're going to be at the peak of the jump. And then we're going to be back on, hitting the ground here while we're slowing down. So this time we're moving down, but our acceleration is up because we are slowing down. Here our velocity was up and our acceleration is up because we were speeding up. Once I've left the ground, my acceleration I know is down because I'm in free fall. Whether I'm at the top of my jump and my v is 0, or whether I'm still on the way up, or whether I'm still on the way down. So we'll have different schemas for some of these now. So we'll have person and earth in the first one. And the person is touching the earth. And there's pushing back and forth, so that's a normal force. There's also the weight interaction. And that's it. So this free body diagram will have the weight down and the normal force up. The normal force has to be bigger than the weight. I know that I'm accelerating upward, so my net force on the person has to be upward. In the middle two, the schema has the same two objects, but the normal interaction is not there anymore. So it's just the weight. So if weight is the only force, well, that's easy to draw then. It tells me my net force is down. So this is the free body diagram all throughout the jump, after the person has left the ground and before the person's back on the ground. So it doesn't matter whether we're going up or at the peak or we're coming back down. This is always the net force. And so our acceleration is always down. When I hit the ground again, it's back to the same schema as the first time. Normal force between them, mg between them. The weight always down the same way. Now since the acceleration is up, tells me my normal force again has to be bigger than the weight. It won't be less than the weight until, or equal to the weight until I'm sort of stopped and standing still again. So my net force has to be up again. Even though I'm moving down this time, I'm still accelerating upward. I know that I'm accelerating upward because I'm moving down and slowing down. So the acceleration has to oppose the velocity.